Thank you, everyone. Okay, so today I'm going to tell you about Arweave, which is the base layer of the Permaweb. So Arweave is at a fundamental level a blockchain redesigned to store large amounts of data inside. Not just large amounts, but like a whole web worth of data inside. Why would you want to do this? Well, since the beginning of recorded history, humans have seemed to possess this innate desire to record information for extremely long periods of time. We build all of these archives. We use unbelievable amounts of resources, actually, to try and store documents for hundreds or thousands of years. And we essentially always fail. Why do we fail? Well, because we use centralized repositories of the information, and they always fall victim to fire, flood, or damage by governments, eventually. So there's another reason you might be interested in doing this too, which is that history is written by the victors. We think Winston Churchill said this, not actually sure because we've lost all the records of it. So if you can build an archive, a data storage system inside a blockchain, you can use the democratizing and sort of permissionless nature of that system to make sure that every person can have the information that they want to have stored forever. They have access to that, which is something that is like fundamentally different than the traditional archiving space. Typically, if you want to store data in an archive, you have to be like a government yourself, or you have to have, tens of millions of dollars at least to get started, if not hundreds of millions. With the Permaweb, what we're doing is essentially making it so that there's one unified protocol for building archives, and then anyone can add to that archive for, I think it's about ½ cent per megabyte, typically. So if you've got a blog post or something that you want to add to the record of history, or a picture or something like this, you're going to be able to do so for fractions of a cent, essentially, which is a massively democratizing force in the space of long-term data preservation. So another reason you might be interested in doing this is understanding that, as George Orwell put it, the person that controls the past controls the future, and the person that controls the present controls the past. So the fundamental observation here is that by changing the way that people think about the future, you change the way that they act. Think about the past, you change the way that they act in the future. If you control the present time, you control information about the past. It's a fundamental tactic of authoritarian governments. They like to control access to information about the past. And we saw this most recently, you could argue, in Russia. Before the invasion of Ukraine, Vladimir Putin spent about a year going around trying to recreate the history of Ukraine. He actually wrote this like 7,000-word essay or something. You can read it online. It's very weird. But trying to, essentially redefine the history of Ukraine such that it doesn't exist, which was a sort of precursor to the action that we now see. By controlling the present, try to control access to information about the past or perception of the past in order to change how the future worked. So, okay, that's why we might want to do this. Well, how do you actually get it done? You have to solve essentially two simultaneous problems. The first is that you need to, I'll actually start with scalability. The first is you need to make it so that a blockchain can actually fit large amounts of information inside. Like normally, a blockchain will fit about a maximum 10 megabytes per minute or something like that throughput rate onto the chain itself. So that's obviously not big enough. We want to put like an entire web inside this thing. That's not going to work. Okay, so you need to solve that problem. You also then need to solve how to make that economically sustainable, right? So if you can store information technically forever, well, you have to have some way to economically pay for it. Scalability, how do we do it? Well, it turns out that basically all you have to do is Merkleize the data. So you get all of the data that you want to put in the system, you split it up into tiny chunks, you then make a Merkle tree of all of those chunks, and you commit the root of the Merkle tree, and then you make the mining process about storing that data. So instead of wasting energy guessing random numbers, you say, hey, go get me byte number 7 billion from the network. Go get me byte number 5 billion. And then you recall them from the hard drives, and you test them for a cryptographic a cryptographic puzzle, essentially. And by doing this, you can enforce that the miners have to replicate the data in order to get paid. Okay, so that's pretty neat. And then on the other side, now you've done that, you have to work out how to pay them. The only way that we think this is possible is using an endowment structure. An endowment essentially is you put a large amount of dollars, one way or another, aside, you make interest on those dollars, and then you use the yield that you're generating in order to pay for some kind of good. Most common example of this outside crypto or outside Arweave actually is in universities. Often you'll find that a university has a massive endowment, and they use this to pay for tuition fees for students over time. They might take 10 or 100 students every year, and they pay for their tuition by just having a bunch of capital and generating yield on that capital. In Arweave's case, we did it slightly differently. We said, okay, well, we can actually get yield from the declining cost of storage. So if you look at your endowment contribution, which is 200 years worth of storage at present prices up front, you see that as the cost of storage declines, you get a natural yield on that. In fact, actually, this is very, very robust because humans love data. And they love making it cheaper to encode data and to store it. So you get a more reliable yield using this type of system than you would trying to bet on the stock market or what have you. In fact, over the last 50 years, this type of system has yielded a 30.5% return in storage purchasing power on average, which is pretty remarkable. But you can't use that yield for anything other than purchasing storage. So it works great for us, but you can't financialize this product. Okay, so what we do with Arweave is we say 30% is pretty robust. Let's build a system that will be stable as long as that rate stays above 0.5%, which is approximately a 60x margin of error. And the idea there is that we really want to build a system that is reliably robust over an extremely long period of time in many different economic situations. So Arweave launched in 2018 and has been growing more or less exponentially ever since. We see that all of this information inside the system, it's about 350 million pieces of data at this point, maybe nearer 400 million at this time, I guess, is available in people's web browsers. And that's something that people find really interesting because it means that you can essentially browse this system as if it is a web. We call that web the Permaweb. It's a global permanent web. That is a booming noise in the back there. Jeez. Okay. So over time, we think that this collection will become the sort of basic knowledge set of humanity. We want to make it so that anyone can contribute any knowledge that they think is useful to other people over long periods of time. But it can also store apps, which is a little bit tangential, you would think. But we kind of see that applications are essentially knowledge for computers. Like, it's how do you achieve a task? And it turns out, once you build applications on top of this system, the permanence of the data gives them fundamentally different power dynamics. So these applications are ownerless, fundamentally. Once the developer has published them, they cannot unpublish them. And that seems like a kind of trivial thing at the beginning, but then when you look into the effects that it has, it's actually pretty profound. So an example is this. This is Arwiki. Arwiki is a fully Permaweb hosted application, which means that Ricky, Arwiki Ricky, as we call him, cannot change this now that it is launched. That means that the code, if you will, is sovereign inside this system. There is no higher authority than the code itself. And what that code says is, we want to entrust this wiki to a DAO. And so you can contribute articles to the wiki, and you can essentially gain some tokens in response. You can use those tokens to elect moderators or to remove moderators. And they're essentially the people that get to choose what is actually shown on the wiki. And this is really interesting because this is probably one of the first, maybe even the first, real-world web applications where the community themselves is sovereign. There is no higher authority. If you try and build a system on Web 2, you will always have a server somewhere that defines what happens when you visit the web service. When you go to twitter.com, Twitter, the company, owns what happens on that platform. If you go to wikipedia.org, the Wikimedia Foundation owns what happens on that platform, just by the nature of the protocol. The information lives in a place, and that is a physical location. Like underneath all of the wiring that goes from wikipedia.org to the data, you're actually just resolving that to an address. So in the Permaweb, it's very different. The data is held in a collective commons, and as a consequence, you can recall it from any different gateway. There are quite a few different gateways now. You could even actually access it directly. And so you just don't have that kind of location locking effect that you get on Web 2. And that means at the fundamental level, when a user comes to use an application like this, they're playing a completely different game of power. This application can't be changed by anyone, apart from the community. But it doesn't stop there. You can build social applications on top of this. For example, you can build a system that is a public square that verifiably guarantees your right to speech. If you can speak there today, you can speak there tomorrow, like, no doubt. As long as you can access the Arweave, this will work. And you've got to compare this to the situation on the centralized web, where basically the person that controls the server controls the speech. It's a completely different game. So another interesting property of these systems is that Permaweb applications preserve what we would call consumer integrity. What we mean by that is when you use a Permaweb application today, you can use it like that tomorrow, for sure. There is no chance that will ever change. Sounds basic, but you've got to compare it again to what happens on Web 2. In Web 2, you have Gmail, for example. You sign up for Gmail, and Gmail says, here are our terms of service. You just click yes. And maybe they're not selling your data today, but you don't know what they're going to do tomorrow. They might well start doing that. In fact, actually, Gmail did this. They didn't mine your data to begin with. Now they do. And I'm locked into using Gmail. Can't really escape apart from Weavemail. And so there's this Weavemail client here, and I can be confident I can use it in its present state forever. If the developer wants to build a new version, they absolutely can. But like a blockchain-like system, I'm not forced to update if I don't want to. I have rights as a user in this system. Another interesting feature is that Permaweb applications require zero maintenance. So as a developer, when you're building a typical web service, you have to make sure that that web service is going to stay online, and you have to administer the servers and so on. On the Permaweb, it's different. We've dissociated code from infrastructure. So you launch the code. That's your job as a developer. You pay for it. It's like that Weavemail application that we were looking at, I think, cost something like 1/100th of a cent to store. So you pay once to store the application for 1/100th of a cent. Then the user recalls the application on a gateway. And that gateway is essentially provisioning the infrastructure for you. So as the developer, I don't have to worry about infrastructure anymore. I just launch the thing. It gets recalled by the user. The user has an economic relationship with the gateway, and that's their job. That's their business, if you will. And I'm freed from caring about it. So you can build a hackathon project on the weekend or what have you. You launch it. It just doesn't break. It continues being served forever. And this is not like theory. We've been running this thing for, I guess, 4.5 years. There's applications from 4 years ago. They work just as well today as they did back then. And the developer hasn't paid a single cent more to host them. And they've done absolutely no server administration or anything else like that. Another thing that we're looking at the moment is monetization on the web. So with the Permaweb, you can essentially embed smart contracts inside the data itself. It's not like an NFT where you say, okay, I've got my smart contract on Solana, Ethereum, whatever it happens to be. That points to a JSON blob, which points to your data, and that's the kind of chain of brittle linkages, essentially, where one of those disappears, the whole thing breaks. Well, on the Permaweb, we built it to be an archive. And that means that you don't just use content identifiers. It's a crazy cult of content identifiers in crypto. They're a really bad idea. You don't just want the hash of the data, because the data itself is almost meaningless. You want to know not just the data, but who said it, and what metadata there was. And in the case of Arweave, it turns out that that metadata can also include contracts itself. So you have an atomic asset, we would call it on Arweave. It's got one address, you know who put the data there, at what time they put it there, the title, description, everything else, and also who owns it in terms of a smart contract, or really anything else you want to program into that smart contract. Yeah, so we think this is a pretty interesting feature of the system. People are starting to use it to build a web that is tradable. Here we have a Reddit-like system on Arweave. It's called now.arweave.dev, or actually now, and then you put .any Arweave gateway and should return for you in the same way. On now, you have assets. Oh, there we go. You have assets that are pages or images and the like on the Permaweb. And when you like them, it essentially generates a profit stream for the person that created the asset itself. And then you can trade that. So this one has a profit-sharing token inside. That means that when people stamp this thing, when they get likes, there's a profit flow, and you can buy and sell that as a user. So that's an interesting thing that the Arweave community is playing about with right now. Okay, thank you so much, everyone.